Introduction to Aerodynamic Objects, Tutorial 7, Propeller Propulsion. And in this tutorial you're going to add a propeller to your aircraft and demonstrate powered flight. So our objectives are to create a propeller from two wing-like objects and attach to a hub. And then we're going to spin this propeller and generate thrust. We're going to add an undercarriage to the aircraft so it can roll on the ground, and then we're going to make a powered takeoff. Scene diagram for tutorial 7 is pretty similar to tutorial 6, except now we have a propeller added to the aircraft, and that propeller is made up of two aerodynamic objects, one for each blade of the propeller. And in fact these blades are going to be made by reusing wing objects, so it's exactly the same concept of having an aerodynamic object, whether it's for a wing, a tail or a propeller blade. It's the same process all the way through. So here we are in Unity. I've created a new scene and it's based on the endpoint of tutorial 6 as before. So we've got tutorial 7 work in progress, and this is exactly where we left off in tutorial 6. So this is a glider that will fly when the man throws it. And what we're going to do in this tutorial is build a propeller that goes on the front that will allow this aircraft to take off under its own power. Okay, so let's get started with this. A bit of reorganization to do, but not so much as last time. First thing we're going to do, actually we're going to call this aircraft rather than glider, because it's a fully functional powered aircraft. And we're going to need a different script to control it because we need the propeller on it. So I'm just going to remove that one, and I'm going to do add aircraft manager tutorial 7. And that's asking me for the center of mass marker as before to get center of gravity in the right place, but we've also now got a control for controlling the speed of a propeller, and we'll need a reference to the prop hub which we can put in once we've built it. Okay, let's get building a propeller. Now I'm not sure whether this is smart lazy or just lazy, but we're going to build a propeller just by duplicating the wings and turning them into propeller. So it sounds a bit far-fetched, but if you bear with me you'll see how this is going to work. So we're going to duplicate the wings and we're going to call it propeller, and let's drag these to the front of the aircraft. Doesn't matter where, we can adjust afterwards. And well, what we're going to do, if we take the z-axis of that, we're going to spin them round. So we're going to make our propeller just by spinning this wing round on the front. Okay, sounds a bit crazy, but actually we can get there pretty quick. So let's make some propeller blades out of these wings. So I'm going to do alt click on that and it's going to open it all. And the first thing I'm going to do is get rid of the dihedral because we don't want that for a propeller. So if we look where the dihedral was stored, it was 6 degrees there. Let's put that as 0, and the same on port wing. In fact, while we're at it, let's relabel these just so we're clear what we're doing. This is call this the starboard. It's not really starboard, but let's call it the starboard blade. That's where it started anyway. And call this one the port blade. When they're spinning around, obviously it doesn't matter whether they're port or starboard, but this gives us a reference to start off with. Okay, clearly very big, so let's make them smaller. So what I'm going to do is click geometry on that one and then control click. So I've selected them both, so I'm doing multi-object editing, and let's make the semi-span, or the span of those, semi-span of those 1.2 meters. We'll make them 1 centimeter thick and a chord of 0.25 meters. Okay, it's looking a bit more like a propeller. If we give it a little spin, we can see what's going on. You may have noticed the green sphere colliders up there from left over from the particles. They didn't get rescaled, so we're going to have to move those. Let's put that one back to 0. So we've got point particles here and we need to move them in. Let's go into top view and just drag that somewhere there, doesn't matter exactly, and the same with these flow point particles, drag it in, and then if that's that one, that one. Okay, we've got our flow particles on. In fact, that one's moved slightly, so let's just move it back that way. Check that one. That one's moved in a bit. Okay, not critical exactly where they go. Okay, so it's looking a bit like a propeller, but clearly it's a flat blade, so all it's going to be doing is producing drag, so we need to set an angle to the wind. So what we're going to do is go to the starboard blade first, and we're going to set that to a rotation of 60 degrees. So this is the pitch angle of the propeller, and if we go to the port blade, we're going to set that to minus 60 degrees. And if you do anything with propellers, there's two things you need to know about propeller: its diameter and its pitch. And the pitch angle of the blades is critical for it's a bit like the gears in a car. That the angle you set these blades determines how the thrust of the propeller varies with forward speed. And sometimes if your propeller's not working, it just means you haven't got enough angle on the blades. And when this plane's going fast, you may find that actually the propeller's producing negative thrust if the pitch angle isn't high enough. Anyway, this will be fine for us for now. Okay, once again, just because it's fun, let's just spin the propeller, and it's actually going to be spinning clockwise as the man sees it, so that's right, so that's going to be generating lift on those blades. Okay, let's do a little bit of work on the aerodynamic objects on the blades. So I'm going to do multiple object editing on there, so control click on both of those. We've got drag and lift, let's just leave that as it is. Something really important is that we have to click the is kinematic box, and what this does is allows the aerodynamic code to calculate the velocity of this panel based on not on the motion of the rigid body it's attached to, but the motion of the panel relative to the rigid body. So if you've got a wing that's fixed to the rigid body, if the rigid body moves, the wing follows the motion of that straightforward. But on this propeller, we're going to be spinning it around here, and it's going to be moving relative to the rigid body. So you need to click is kinematic. So if you're making a flapping winged bird or an insect or something where there's some part of your vehicle or animal that's moving relative to centre of gravity, you have to use the is kinematic option. Okay, that's all the same. Let's get rid of the wind arrow. We don't need to see that. Yeah, let's see the lift arrow, but tell you what, let's make it a bit smaller so it's not too intrusive. And let's do that at 0.02. We can leave the sensitivity as it is. Drag arrow, we could see that, but actually let's get rid of it so it's not in the way. Okay, that's looking good. So we've done that on both of those. The other thing we're going to do is, and this is an aerodynamic thing, but if you're modeling propellers, generally if you're taking a control point on the propeller to work out the aerodynamics, you normally take 75% chord. So if you imagine when the propeller is spinning around, the outer bit of the propeller is spinning much faster than the in bit. So actually if you're modeling the aerodynamics of it, it's better to take the average velocity somewhere out here, and the general practice is to take it at 75%. So what we're going to do is actually shift our aero object meshes out a little bit so they're consistent with where you'd expect the propeller to be modelled. So we're going to do that by going to the aero object there, and we just want to shift it out, and because it's all scaled we can just shift it by, if we do 0.25 a quarter, that's just going to shift it out from halfway to 3/4. And if we do the same on this one, it's in the other direction now, so we need to do minus 0.25, and that shifts it out there. And really this is also just illustrating the fact that when you're looking at the graphics, that's graphics for you. This mesh here is what's doing the aerodynamic calculation work, and so it's always an approximation. The aerodynamic object is just taking its data at one point on the object, so in this case it makes sense to move it out. Okay, I'm liking that, but it doesn't look very aerodynamic at the front, and just because we want to make it look slightly nicer, let's put a little nose on the front, a spinner on the propeller. So if we go up to propeller, 3D objects, and then we want a capsule. Drops in a standard capsule. Let's click equal scaling and 0.2 size, and then let's just rotate it round. How does that look? That's alright. Let's move it forward just a little bit. Doesn't really matter, it's just as long as it's somewhere roughly at the front, it's going to do its job. Okay, getting there. But as an aircraft designer, when I look at that, I say there's no way that's going to balance with the weight of the propeller at the front. It just doesn't look right, does it? So the wing looks too far back. So what I'm going to do, because we can, is just move the wing forward. Move it about. Yeah, that looks better. And I'm also going to move the centre of gravity forward, because I know for stability reasons it needs to be between sort of 1/4 and 1/2 back from the leading edge. And this is where the magic happens with aerodynamic objects. We're just moving things around, but the code underneath just says fine. That's where our wing is, and it does its calculation, and we're all good. Great. You may notice a design flaw with this aircraft in that if the propeller spins around, it's going to hit the ground. So what we need is some undercarriage. And in fact, I have one prepared earlier. So in the prefabs folder of the tutorials, you'll find something called undercarriage. And if you just drag that in and drop it onto aircraft, the little wheels appear under there. And the general rule of thumb for tail dragger aircraft is that the front wheels need to be just ahead of the centre of gravity. Doesn't matter exactly, but it just means that when the thing's sitting on the ground, the centre of gravity is behind the wheels and the tail is on the ground. Okay, that's looking good. Just in terms of pre-flight checking our aircraft, notice that our tail is still bent over from our previous tutorial. So while we're here, let's sort the tail out. So if we go to tail, vertical stabilizer, it's got a 6-degree angle on it. Let's just straighten that up by putting that at 0. Okay, that's good. Okay, nearly there. If we start now, we're going to squash our aeroman, so let's just be courteous and not drop it on him, and let's put it near the ground but not in it, so it will just drop slightly and settle on its wheels. Okay, let's just try that. Okay, that's fine, it's sitting nicely on its wheels. We've got the wind zone left over, the fluid zone left over from the last tutorial, so we've got our rising wind, which we're not going to need because we've got a propeller. So let's go back in and let's just turn that off completely. And we're almost ready to fly, but before we do that, let's be responsible and do a thrust test. So whenever you fly a real aircraft model or otherwise, before flying with a motor on, you always do a test on the ground to make sure the motor's working before you commit yourself to flight. So we're going to do that by going to the rigid body and setting that one as kinematic. So it's a slightly different function here, but this means now this can't move. And we now finally need to connect up the propeller with the code that's going to make it spin. So we're missing here a reference to the prop hub. So I'm going to drag the propeller into there. And fingers crossed, we've got it all set up. Let's try it. Okay, so it's sitting there in space, not doing anything. Let's try speeding the propeller up. Okay, propeller moves. And there we go. Our propeller's spinning. It's clipping the ground a little bit. But there you can see we've got our green arrows on the front. And if I pause it, you can see those green arrows are basically what we saw as they were our lift arrows on the wing. The aircraft isn't moving, but the propeller is spinning round, and those lift arrows coming out the center of where we've got these objects, 0.75 along the blade, is generating lift, and that turns into thrust on the aircraft. Great. So I think we're ready for our first flight. So what we need to do is disable is kinematic, and let's give it a go. So the little man, aero man at the back now, is just waving off his aircraft rather than holding anything up. I'm going to turn off the stats for now. I think we're ready to go. So fingers crossed. Fire up the propeller. Starting to generate some thrust. Going along the ground, wings are lifting, and there we go. We've done our first powered takeoff with our aircraft. And there it is, flying. It's climbing, doesn't need any vertical wind. It's just flying on its own half. You may notice the plane is flying in circles, even though we've got the fin straight, and that's a true aerodynamic effect. Happens on real aircraft. There's drag torque on the propeller when it's spinning around, so there's drag on those wings going round. And what we're seeing here is that's the drag torque is actually tipping the plane over, and if we span the propeller the other way, it would turn the other way. And well, let's look at our stats. We're getting 600 odd frames a second with that. So we're doing quite a lot of aerodynamics in there, number of panels, spinning propeller, but really it's quite a low load in terms of calculation of what's going on. We're also obviously generating quite a lot of particles as well. Great, so what else can we do? One thing that's interesting, if you actually turn the propeller down in flight, you can see it will come gliding back down. It's a sort of very crude way of controlling it. And then we did a little touch and go there. We can take off again. But we're really only got one control, and that's just thrust. We'll come in again and try and do a landing. So I'm just going to turn the propeller off. And there we go. We did our landing. Fantastic. So we've got a flying plane. It's got its own propulsion on it now. We can just about steer it around in the sky. But what we're going to do in the next tutorial, fairly simple really, but we're just going to add some really basic flight controls to the aircraft so that not only have we got propulsion, we've got the ability to control it in pitch and yaw whilst it's in flight.